Well, I said Rosemary first. So, Rosemary, you have to react first. Act natural. Go.
I can't. I'm not an actor. I'm an engineer.
Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the UPTIME podcast, bringing you the latest in wind energy tech, news, and policy. All right, welcome back to the UPTIME Wind Energy Podcast. I'm your co-host, Dan Blewett. On today's episode, number one, today is our 100th episode. So can I get a woo from the crowd?
Woo!
Woo? Someone? All right. There's our very nerdy celebration for everyone. But we do greatly appreciate you being with us here for 100 episodes. So I guess, Alan, it's got to be, almost 2 years to the close into... I guess maybe we're a month away, right? There's 52 weeks in a year.
Mm-hmm.
I know math. But yeah, it's been a good 2 years, and we appreciate you listening. So on today's show, we're going to talk about offshore wind farms, maybe doubling as carbon capture devices. We'll talk about a recent rotor crash off a Siemens Gamesa wind turbine, which seems strange. The shakeup in leadership at the top of Siemens Gamesa. Talk about a recent ship that's collided with a offshore wind farm, kind of adrift at sea, which is also crazy. And we'll chat through a little bit about ships in general and the offshore wind projects that they're going to have to serve, and they're kind of outpacing those. We'll also talk about Louisiana. They've got some offshore wind goals that might be, in harm's way, Hurricane Alley down there. And then lastly, we'll talk about a new impossible, quote unquote, material that's stronger than steel and as light as plastic. So we'll see what our composites experts here think about that. Before we get going, be sure to subscribe to number one, Rosemary's YouTube channel, which you'll find in the show notes below, and UPTIME Tech News, which is our weekly email update about the podcast and current events here in the wind industry. So first thing is this crazy rotor that fell off the term fell off seems really, flippant and weird to use about a huge industrial machine, but it's kind of what it seems like. There was a 2 megawatt G97 turbine on a farm in Brazil. And it looks like the nacelle's fine, the tower's fine, but just the rotor fell off. Rosemary, how?
Yeah, it's crazy. What is that? It looks like it's, I don't know, did they forget to install some bolts, or maybe there's even some evidence of overheating or fire? I see a lot of brownish black residue on there, but yeah, no, that is crazy. And I mean, it can't just be like one faulty bolt or something. It's got to be some incorrect installation procedure, surely, to see the entire rotor just fall off.
Yeah, it says it came online, the wind farm, on 2014, so it's 8 years old. So did something like a bolt shear off maybe and allow this to just... Because it really looks like, I don't know, I feel like this should be held in pretty well. Like, you don't hear about this very often.
I was going to say, maybe they weren't maintaining properly. They weren't checking the torque on the bolts, and some wriggled loose. And, once a couple of bolts wriggle loose and something breaks, and it puts a lot of stress on the other ones. And so you can go from having a really high safety factor to having a negative safety factor if you don't address it. But usually those maintenance procedures for major components like that are pretty dialed down. So yeah, I guess something has gone wrong there. That's an understatement.
It would have made a little bit of noise before it fell off, you think. It would have rattled, squeaked, something, overheated. You would have saw smoke coming out, something in there before it decided to fall off. That's a really catastrophic event. I've never seen that kind of damage. We've seen blades break off all the time, but to have all 3 blades come off at one time, that's scary. That is scary. It's dangerous if you're around that, for sure.
Yeah, it must have been really interesting to watch that if anyone had seen it, which gives more credence to my desire to have 24/7 video surveillance of all these wind farms, just so we can see the cool stuff that happens when things occasionally go wrong. So But yeah, well, we'll check back and see if there's more reporting about that, about what actually happened. Because it does seem like a really oddball failure. So moving on, offshore wind, there's an interesting article in Fast Company about them potentially doubling as carbon capture devices. Rosemary, you're our carbon capturing expert. Is this something you see as, there's a big trend of like, hey, let's combine everything that we can and make this, everything's an ecosystem, right? Is this one that's going to make sense in your opinion?
Yes and no. So the yes part of it is that I do think that it definitely makes sense to co-locate direct air capture with where you're going to store the CO2, because that can cut out a lot of problems if you don't have to worry about transporting, compressing and transporting CO2. So if you put direct air capture directly above some, storage reservoir or the correct geological formation, then I think that you can cut out a potentially big problem. But the two downsides to it that I see are, one, anytime anyone's planning to use just excess electricity, excess green electricity to power something, whether it's, hydrogen production or direct air capture, you usually see a lot of those kinds of plans announced. And then if you track the projects as they progress, they almost always move away from just using, these intermittent, cheap periods of electricity, because you find that you need to operate your equipment for much longer periods to be able to make it economical. So, if you've only got, say, negative electricity prices, even where they're very pervasive in some parts of Australia at the moment, it's, still only around 10% of the time. And if you buy a really expensive piece of equipment, then you don't want to only use it 10% of the time. So you inevitably end up needing to operate it more and more and more to make the cost of what you're trying to do cheaper. So I think that's it's unlikely that we would see it used in that way. And then the other aspect that will make it challenging is that direct air capture is a pretty immature technology, and the idea that you would then go put this, new maturing equipment offshore is, I say this every time anyone comes up with a crazy offshore plan, but, you just really complicate your learning curve if you need to get a helicopter every time that you want to tweak something on your equipment or, repair something that failed and you needed to redesign it. So I think it'll be a long, long way in the future before we actually see a plan like this come off. But yeah, I think overall the idea of storing CO2, capturing it where it's stored is a solid one.
So Rosemary, I think I looked at the numbers of systems you would need to actually get to and the number fluctuates, but I think you need to pull like 100 gigatons of CO2 out of the atmosphere. That's the general claim right now. But one of these systems, like on all of the East Coast of the United States, would pull out 500,000 tons. So you start running the numbers. You need about 200,000 of these units along the East Coast to get enough carbon capture out of the air. And so the math in my head didn't work. Like that 200,000 of these systems is a lot. And if we're only relying on that little sliver of time to pull energy, basically the free energy out, doesn't seem to make a lot of sense. But I saw some Twitter stuff from you this week, and so I'll mention it. I noticed that you were talking. Oh no, I saw your video. I saw your YouTube video, which is very good, by the way, about hydrogen transport.
You're in trouble now. Alan saw your tweets.
You were talking about hydrogen transport and all the complaints from the clean energy people saying that's crazy. It's too much money. Why would they do that? It's a waste of time. And your response is like, well, let them try it, then we'll find out for sure.
Yeah,
let them do it.
Yeah,
fine. It's their money. Let them try it.
No,
yeah, I think the same thing here, this carbon capture.
I agree. And it's something that I've learned this from experience in my career, managing technology projects. You have a lot of diverse minds on your team, a lot of very smart people who don't always agree. And oftentimes, there's competing opinions about which is the best way to do something. And if you just let engineers be engineers, then you'll just talk about it every single meeting for, years if you don't stop it, getting more and more involved in your analysis. And sometimes you've just got to say, you could try this out in 1 week, try it, see if it works. And the beauty of that is that somebody who has actually tried to make something work and found that they couldn't, legitimately going to change their mind about what they think is the best thing to do. Whereas if you just argue with them and try and reason, it's so unlikely that people actually change their mind that way. So I think with the hydrogen economy, we really do have too much talking, too much analysis. And even though I got a lot of criticism on that particular video that, we already know that liquid.
You did?
Yeah.
I was shocked.
I wasn't shocked. I already knew that it was not the mainstream opinion. But people say, we already know that liquid hydrogen transport doesn't make sense, like from a technological point of view. But everyone doesn't know that, because if they did know that, they wouldn't still be pushing it. I really don't believe that everybody who, is interested in these technologies is just, some PR person for the fossil fuel industry. There's a lot of well-intentioned people, and I think that those people will change their minds if they see that it's harder and more expensive than they thought. And, maybe we're the ones that are wrong, and you've got to, keep an open mind. And if it works out really well and makes a lot of money for the people involved, then we'll see them roll out. So we'll know how it worked out.
I mean, almost every renewable energy source right now that we have started because someone was crazy enough to try it. Especially like wind energy. Yeah. That's totally the place it came from. We're just going to try it and see what we can do, right? And all of a sudden, we're making 15 megawatt turbines. It started with an idea and somebody trying it. So I think that's totally the right approach.
Yeah.
Let them try it, and maybe it'll work.
Yeah.
Great.
And a lot of really dumb ideas have dropped out along the way as well, including some that were sounded great, but just proved to be too difficult to implement. And direct air capture is really interesting because, on the one hand, it's so dumb compared to if you want to capture CO2 out of the atmosphere, you pay at least hundreds of dollars a ton, and probably more like $1,000 a ton. And if we're doing that at the same time that we're continuing to emit from sources that we can easily replace if we had $1,000 per ton of CO2, there would be no question you would close every coal power plant on the planet immediately if there was a $1,000 a ton price on CO2, and many other sources that you can easily change to get bigger reductions. So on that sense, from today's point of view, it doesn't make any sense, and it will never make sense to do direct air capture instead of decarbonizing. And I think that a lot of the time when people talk about direct air capture, especially articles that are written about it, it's from the point of view that we can do this instead of decarbonizing, and it just is never going to work that way unless you want to just pay ridiculous amounts for your energy. And also, direct air capture uses a lot of energy, so we have to make more energy and pay more for it. I mean, it's right. A crazy way to approach the energy transition. But if you think of it as something to do after we have decarbonized, then I think it's really important that we are making advances in that technology now, so that in 20, 30 years, when we have got rid of everything that is remotely easy to do with decarbonization, that's there for the last bit.
Well, speaking of transitions, Siemens Gamesa's had a number of them recently. This one with their CEO. So Andreas Nouwen was their CEO of Siemens Gamesa from June 2020. He's going to be stepping down later this month. Of course, he was the CEO of their offshore segment from November of 17 to June 2020. So about 5 years at the helm of their smaller, their offshore unit only, and then the entire wind unit. So, Alan, it sounds like this change from your perspective is that they need maybe a leader who's got more experience in getting them through this sort of supply chain crisis that they're going through. So the person they've tapped here is Jochen Eichholt, and he's got an engineering background, and he's a board member at Siemens Energy. Alan, I mean, what's your take on this shakeup? Obviously, they've had two CEOs in, 3-year period now? It's a pretty short period. And it seems like they're just trying to get this ship sort of back on course. Right.
And I think if you're watching from the outside, you think, oh, there's the CEOs are changing. There's a lot of turbulence. There is unstable situation at the helm of these large companies. Well, the fact is that so much has changed, and the way that the wind energy business is evolving right now, where prices are being driven down, and you have supply chain issues, and you have raw material price increases, that is a really challenging environment. And for those specifics, that type of business environment, you want somebody who has dealt with those specific issues before. It's like a skill set. If you've ever been around supply chain when dealing with supplier issues, it's a real talent. You have, and it's not just the CEO, really. It tends to be a lot of the upper level management needs to change focus and maybe change positions, because you're going to bring in people who have a direct skill set to making sure that suppliers deliver on time and that they're delivering the product you paid for. And those conversations between suppliers in your supply chain can get really rough. Many a time in my career, you're kind of walking by the procurement area and you just hear yelling and screaming. And it's a tough world. And that's the kind of sometimes that's the personality you need to move the business forward. And when you're in a more pleasant environment like you were sort of pre 2019 on, where you're just doing R&D, you can't lose, you're winning contracts, that's a different kind of person to drive the company forward. But if you're trying to basically get the legs back underneath a company, it takes a certain skill set. So this is expected. I don't think it's going to stop here, actually. I think a lot of the companies, if they're not changing some of the leadership, some of the people they're going to bring in underneath of them are going to change in the next couple of weeks, really. Yeah, well, Rosemary, you've worked at one of these companies before. It's stressful, right? As an employee of a large wind energy organization, when you see changes at the top, usually when I worked at a company like that, I would be really hesitant. It's oh no, things aren't stable. My job may be at risk. That's probably true right now.
Yeah, I think so. I mean, you don't change CEO twice in 2 years because everything is hunky-dory. I think it's not like it's unusual for Siemens Gamesa that they're facing these challenges. Everyone in every industry, not just the wind industry, has massive supply chain problems at the moment. But yeah, it needs a big shake-up in strategy. So, it's good that they've recognized that and that they're, bringing in what they need. But of course, the employees are going to be disrupted, and it always brings in changes to the way things operate and a changing of priorities. So it can be very frustrating.
Sure.
If, you thought you were working really hard on a high priority project and that gets that gets dumped when leadership changes. It's demotivating. So I guess they'll have to manage that situation as well.
Well, moving on, there is a crazy situation out in the ocean. A transport vessel, the Julietta, has collided with another tanker and then was set adrift as the captain and first mate maybe abandoned the ship prematurely. They have actually been arrested, and they're trying to figure out if they abandoned the ship too soon, because they're supposed to stay on there unless their lives are essentially, I guess, in immediate peril. So pretty interesting situation. And the ship was just adrift, collided with a offshore wind pylon. Is that right, Alan? Yeah,
piling that was planted in the seafloor, which is double scary, right? For everybody's sake. And I hadn't seen that happen before, but as we put more and more pilings out in the ocean, eventually some adrift ship is going to run into them. And it had happened before, back in like 2014 or 15 around the UK, that they had a very similar situation happen. And that's very worrisome, right? That I think in both cases, there weren't wind turbines on those pilings at the time. But as we get more and more wind turbines offshore, it's inevitable, right? I mean, the situation that happened over in Denmark recently was just a really bad weather condition, and two ships met in the middle of the sea. What are the odds of that, right? And then combined with the video I saw was they were pulling the crew off the ship with helicopters because all the controls had gone out and it was just adrift at that point. But the chances that it runs into a wind turbine are relatively high, especially off the east coast of the United States, where we're going to put thousands of these things. It will be a problem. And I always wonder, how do you even address that? Do you address it, or you just say, you know what, it's one of those, does the insurance company start paying out? Who handles the loss there? Because it's not an act of God, right? It is a foreseeable thing.
Yeah, I think the ship needs to pull over and then exchange insurance cards with the wind turbine. And, wait for the Coast Guard to get there, and they'll hash it out. And Yeah, that kind of situation.
Yeah, who the Coast Guard's going to love that one?
I think it collided with another ship as well before the wind turbine, didn't it?
Right.
A ship that was carrying chemicals or something. So I would assume, I have no knowledge of the industry, but I would assume that the ship has insurance and that is going to pay out for damage to other ships and wind turbines that it's hitting, like it's just, floating around like it's in a pinball machine or something. It's obviously not an ideal situation.
Yeah, it was an oil tanker that the Julietta hit. The Julietta is a cargo ship, and they hit an oil tanker. So luckily, it doesn't seem too terrible considering all the, possible ways it could go down. But still a pretty crazy situation. Obviously, there's going to be more traffic in these areas where there's wind farms, but I don't know. I assume that they have sort of ship traffic control, just like air traffic control. It's going to give them some buffer as they make these routes around. I don't know. I'm not sure how all that works, but you think that they're already starting to plan for this kind of thing. This seems like it's probably exceedingly rare that this would happen.
I hope so. It better be as we go forward.
Obviously, offshore wind construction is rapidly increasing in speed. And a lot of these vessels, which we've talked about a little bit in the past, that these vessels have to get bigger and bigger to install them, these jackup vessels. And it looks like we're going to continue to outpace the creation of these ships with the creation of these wind farms, where there might be a bottleneck in the future. Alan, do you see that this is maybe going to hit that sort of constraint point where we just might not have enough ships to get this done? Or do you think people have already started to forecast this out and maybe these shipbuilders are already well aware and well ahead of this issue?
Yeah, and the interesting piece of the United States is we have laws that prohibit the use of ships built outside of the U.S. to do sort of U.S. to U.S. duty. And there isn't any, but they don't have any ships built to put wind turbines out in the ocean at the moment. So I'm not sure how that's going to work. I think the first one's supposed to come due in 2023. But I learned an interesting measure, which was, I think the term was ship years, the number of ships and the number of years they would need them. So we need like 70 ship years to do all this wind turbines we're talking about on the East Coast. You're like, well, okay, if I have one ship, it's going to take 70 years. If I have two ships, it's going to take 35 years. Like, okay, there's a balance in there. The question is how,
like man hours. Like man hours,
right? But it's like, but it's ship years. Like, oh, okay, I guess that makes sense, right? But how many ships do you build? I think that's the question. Like, how fast? If we have a 2030 deadline to put all these wind turbines out there, and it's sort of back end loaded, but it's years 2026 to 2030 is when probably most of these things are going to happen. You're still stuck, right? You're trying to do 70 ship years in roughly 4 years, so you're going to need about do the math, right? It's a lot. 20 odd ships probably. That's a lot. And if they're only used for a couple of years, do they pay for themselves? And so the whole thing just seems to be a little bit of a jumble right now. And I'm not sure there's any simple answer to this question of how many ships you're going to build. Or I think what's more likely to happen is they're going to give a waiver on the Jones Act and let other ships come in there temporarily, because Massachusetts, New York, Connecticut, New Jersey, all these states that are trying to do this renewable energy piece offshore want to get them done. And if there's no ships, the states will start complaining, and rightly so. They should complain. So there's going to be a real interesting conflict happening at the executive level in the United States, because the Biden administration is pretty pro-union, and I would assume there'd be pretty much pro-shipbuilding in the United States. That'd be something they would promote. At the meantime, you're at conflict with the states that are trying to get these wind turbines installed. So who knows right now? I just think the effort is massive. Massive.
I guess if there was, like, if there's shipbuilders or companies that, run shipbuilding operations, if they really felt certainty about the pipeline of offshore, then it would be very obvious that they would invest in a bunch of ships. So my assumption, given that we foresee this shortfall, my assumption is that they're not feeling confident that this, 10, 20, 30 gigawatts over the next decade is actually going to go ahead. So maybe there's maybe that's the root of the problem, because I mean, if ships are going to be in very short demand and you've got cornered the market, then that seems like a really good way to make a lot of money. So
yeah,
but what you wouldn't want to do is to build 10 ships and then find out that the plans didn't go ahead and your ships weren't doing anything. So I guess that's the risk reward that they're trying to balance.
That's what we do at the Olympics every year. A country builds like a gigantic $2 billion stadium, and then it's never used again, and the whole Olympic Village goes quiet. So I feel like, probably get away with a couple of ships, but you're right. It's complex math, it seems like, to figure out how many we should build, how fast it needs to get done, and then what do you do with them afterwards? Yeah, I don't know. Maybe you wonder if they can figure out that these ships can be, all right, when it's done, its lifetime, we can just convert it to a cargo ship and sell it off to Maersk or some other company.
They can haul hydrogen.
You wonder what their like base platform, if they have like a base platform, kind of like anything else, where once it's done this part of its service life, we can just swap out some components and make it useful somewhere else. I assume that's probably a thing, but I don't know.
Do you think that this pipeline is just going to switch off in 2030, though? I would have assumed, that's the intermediate target for offshore wind, and then we want more after that.
That's a good point. Yeah, probably won't.
Because it will only be, offshore wind will only be cheaper and more reliable and more better understood by then. So I would expect that, like if you look at the history of installations of solar or onshore wind, it's all exponential curves. We're still on those exponential part of the curves for the most part. So I would expect that we're just going to, accelerate into the future. So I'll be really surprised if, 2030 comes and on the 1st of January, everyone converts their ships over to doing something else. I expect that there'll still be demand for installing more offshore wind farms after that.
Well, you also wonder what's powering these ships in 2030 or 2040. Is it still diesel, or are they powered by hydrogen or electricity or some other form of fuel? I don't know, Alan. Stuff like that requires so much torque. It's probably going to be a pretty slow conversion, I would assume, to other sources, right?
Yeah, and there's a lot of discussion in the United States at the moment, and I think this is going to play out in the rest of the world, where with ships, they have to be greener, essentially. And the only way that ships are going to be greener is they slow down. Like a 30% decrease in speed to reduce the emissions enough to meet this UN charter requirement, which who knows if everybody's going to live up to it or not. But you got to wonder if it's going to force some of these ships to change their energy sources, right? That they may make a switch to hydrogen just so they can go faster. So it's creating this weird marketplace. And at a time where shipping is a priority, we've put some extra constraints on them, and it's going to get really tough, I think, over the next couple of months. And then throw in that we're going to be building offshore wind turbine ships. It's going to be super chaotic, I think. We're just seem to be able to creating more chaos than we are trying to tamp down the chaos at the moment. And I can't figure it out, really. It's hard to imagine that we could actually make things more chaotic than what we went through the last couple of years, but we're working on it right now.
Well, speaking of offshore development, Louisiana, obviously a state here in the U.S., they've announced an offshore wind goal of 5 gigawatts by 2035. So they're pushing it back. Alan, why do you think they pushed the goalposts to 2035? Everyone else wants to do 2030 because it's a real spectacularly round number on an even decade. But are they like, hey, guys, we'll give us a little more time. We're a little more laid back down here. We need more time for jazz. We'll get there when we get there.
Maybe. Well, maybe they're going to buy these offshore wind turbine ships at a discount because they'll be sitting with for sale signs on them. They can buy everything at half price. That's maybe part of the answer. Like, you don't want to jam up the system with more going on simultaneously because you don't have any way to do it. So, and there's just the part about Louisiana always scares me because every year we hear about these horrible hurricanes that come through and wipe out everything. And I'm thinking, man, I'm sure people like Rosemary are designing wind turbines to handle a Category 5 hurricanes. That seems doable, probably, but it just doesn't feel right. And if you're going to rely on wind turbines and the cabling that brings them on shore, I think you also have to harden them like crazy to make sure they can handle those 1 to 2 massive hurricanes that happens. Can we even do that? I don't know. And I think Rosemary's response is, well, you have oil rigs out there. And yeah, we do, but they don't use the wind to generate power, right? Or they're pulling oil from the surface of the ocean. They're not tied to the speed of the wind. Yeah. They seem wholly different. And have you designed wind turbine blades, Rosemary, to handle Category 5 hurricanes?
I mean, you definitely could. And every now and then I see an article about someone who has designed a hurricane-proof wind turbine, usually not a major manufacturer. It'll be some, small startup or often a research group. But it's not a matter of can you design something that strong. It's a matter of how much will it cost to design something that strong. And is the electricity that you get out the end of it, is that, is it still economical if you've had to make your turbine 5 times as strong? So that's the real question, and I haven't seen anybody come up with a favorable outcome from that analysis before. But it doesn't mean that we won't. If they want them bad enough and are prepared to pay what it costs, then there's no engineering reason why they can't have that and have it safe.
Well, on the other side of it, would you just make it, because that how sometimes they have like breakaway stuff where if something's going to fail, they want to like kind of fail easier and just like it'll go like. They could just, instead of making them hurricane proof, they're like, well, if it gets to like super duper Category 5, it's just going to go into the ocean. Then it's going to be fine to stay there. Like it's coral, like we talked about before, like they just build in, if a hurricane knocks us over, or it's good just to leave it. Like it's fine. Would that ever be a thing? Or is that just another nonsense idea for me?
It depends how often you expect it to happen. If, you're trying to deal with a 1 in 100 year storm in that way, then maybe. Yeah, and I do see people propose designs like pretty commonly, actually, especially in small wind turbine design. They design it so that it's got some sort of hinge that in really strong winds it will fold and can kind of collapse and make a less drag for the wind. But again, I've never seen anything like that commercialized, and it's because if you add a hinge or a moving part, you're just adding a failure point to the design that it might fulfill its need every 100 years, but then you're probably going to get a lot of failures when you didn't intend to, just in normal operations. So they don't usually end up being a really good overall solution.
Well, then, in the spirit of what you mentioned earlier, Rosemary, do you feel like it's probably just going to be a good thing for the industry for a pretty big hurricane just to come through sooner than later, just like get it out of the way? And just like, let's see how they fare, rather than, 20 years down the road where we've installed 1 million turbines and then a hurricane comes through and you realize, oh, maybe they don't hold up as well as we thought. If this hurricane had hit 10 years earlier, we could have already been on generation 6, and we would have learned from it a long time ago. Is there an advantage to maybe it happening now, or would you rather it still get put off in the future?
Well, that's interesting because normally I'm always saying just try it. But this is one situation where I think that you can definitely use maths to tell you what's going to happen in this situation. You can tell when you've got a paper design, and as long as you know accurately what the wind speeds are going to be, then you can already know what's going to happen. You can, and so no, I don't think that we should be installing a bunch of turbines that we're not sure if they're going to fly away when a tornado comes through. So yeah.
But we're not really going to know until it really gets tested. Yeah, I'm not saying that they're not tested, or that they wouldn't be. Clearly, they're built to withstand that. But like you said, there hasn't been a Hurricane Katrina go through any of these, right? I don't know that's happened over in Europe or anything, right? They don't really get hurricanes there.
Not like we do, no.
Yeah, and I mean, I would recommend that they start out small, but they don't put up 1,000 wind turbines, and then, before they experience really, really strong wind speeds. So from that point of view, I agree.
The winds in the Gulf of Mexico aren't particularly strong. They're like the average winds are 7 to 8 meters per second. So it's not the strongest winds in the United States, not even really close. I think it's just more consistent wind. And so you're going to have wind turbine designs that are probably larger rotors because the average wind speeds are a little bit slower. And I start thinking like, okay, we're roughly at some 100 plus meter diameters now, 150 meter diameters now. You're going to be in probably the 180, 200 meter diameters by the time this thing rolls around. And that's you start doing the math on that, you think, wow, that's just really massive articles of wind blades and towers and nacelles, and multiply that times the wind speed. It's just a difficult problem to solve. Let's say it's not solvable. We put a man on the moon, we can probably figure out this one. It's just a question of the unknowns that you always find out the hard way with.
Yeah. And I think it is a tricky economic problem if you've got moderate average wind speeds, which is when you're generating your money, right, from the wind speeds that you see while the turbine's operating. So if they're moderate, but your extreme winds are very high, that's a bad combination because you don't generate any more electricity because you got strong extreme winds. You're obviously not operating through those events. So you're just paying to withstand it, but not really benefiting the rest of the time. So I think that's why you haven't seen a whole lot of development of wind farms in those areas, because it's a lot more cost effective to put them other places.
Well, as a side note to this whole conversation, Fred Olsen Wind Carrier, they are launching an IPO on the Oslo Stock Exchange, and they're one of the leading installers. They own 3 jackup vessels. So as we talk about, the demand for jackup vessels and offshore wind installation, maybe there'll be more companies like Fred Olsen going public where, they can try to boost their coffers and get more investment in more ships and, and grow. So seems like people are already starting to think about, obviously, that direction. Because as we mentioned one of our previous episodes about stocks and where wind's going, a lot of these peripheral industries, even if it's tough for the OEMs to make money, a lot of these peripheral companies like jackup vessels, they might be in a boon where they're servicing it and everyone else around, except for the OEMs themselves, have a pretty good profit to make here. So we'll see how that continues to play out and if other companies start to form to meet that need as well. So last on the lineup here today, MIT engineers say they've created a new substance. They've polymerized a material in 2 dimensions, and they've created something that essentially is stronger than steel and as light as plastic. Alan, materials like this, there's a lot of very highly complex science behind it. Mm-hmm. What are they claiming that they've done here?
Well, it's not just MIT. I did some research on this, and there's other groups that are working on similar technology. I guess it's the manufacturing method, the way to sort of upscale this thing. What they're trying to do is like epoxies and other thermoplastics. They're like spaghetti in terms of they have these long chains of atoms that are stuck together, and that's what makes them strong. It's unlike metals, which tend to be sort of crystalline structures. So your steels, your aluminums, and all those great metals that we use for structural things have that crystalline structure. And that's why we heat treat them and do all those crazy things that we do, because we're trying to control how those materials are formed in this really tough crystalline nature. The problem with doing it in plastics is you can only really make solo chains like spaghetti. So the talk has been can we make them into sort of 2-dimensional plate shapes, platelets I would call them, that if you can start connecting these chains together, you have a much stronger, more durable material. The problem has been trying to manufacture it and also to get consistency of it's like heat treating steel. You really have to get consistency in what you're doing because you're relying upon that quasi-crystallinity for strength. And if you don't control the manufacturing of it, you will have garbage at the end, something that's unknown, which is not what you want. So and Rosemary, you chime in here, but if you had an epoxy system that was much stronger and lighter than what you have today, I think you totally use it. You get rid of the tower. You get rid of the steel tower. It'd be cheaper to make it out of a strong plastic material. There's so many applications for this technology, even if it's still a little bit in its infancy. The huge possibilities.
Yeah, it sounded really interesting to me, the two-dimensional nature of it instead of just having like a bulk 3D kind of structure. So that's interesting. With these kind of developments, the question is always, how far along in the development are they? And once I think that they're still making quite small samples of this now, way smaller than anything you can do anything practical with. So obviously there's challenges when they scale up. Usually they uncover problems that tend to make it more expensive and reduce the properties a little bit. We'd have no clue at this point how much that's going to adjust. So, yeah, it'll just be interesting to see how close to the currently predicted specs, how close to that we end up once they're able to, roll off lots of square meters of these kind of films. But it does sound really interesting. And you can imagine combining it with a lot of other materials to, just use materials a lot more efficiently and get some really good properties out of the whole composite structure as a whole. So I thought it was pretty interesting.
Yeah, and one of the things I took out of this was it's sort of the predictions of the future, right? That if you ask somebody what's the future look like 10 years from now in terms of how we build buildings, how we make wind turbines, how we do anything else, most people will tell you it's going to be very similar to what we see right now. And then, boom, here comes this new technologies, this quasi breakthrough, I'll call it, that could be turned into large-scale applications and just totally wipes out all the predictions we had for what the world was going to look like 10 years from now. And I think that's the hardest part of all these technologies is that the rate of change in what we are doing now is so fast that it makes the predicting the future really, really hard. Maybe 2-3 years out, I think we have a pretty good shot at that. 5 years out gets a little murky. 10 years, it's a crapshoot. I don't think we can do it. But that's where we are right now. And I just like we talked about in putting wind turbines in the Gulf of Mexico, I have no idea what they're even going to look like in 2035. They may be totally different. They may be vertical axis wind turbines. Who knows, right? that's the crazy part.
If Blade Runner has taught us anything, the world does not change as fast as we think it will.
Yeah, right.
I remember 3 years ago, because Blade Runner, the original, was set obviously it came out in 1982, but it was set in November 2019. And when we hit that date 3 years ago, everyone was like, oh, it's Blade Runner year. We made it. We don't have any of those things. We don't have replicants. No. We don't have an off-world place where we're mining. We don't have flying cars. We don't have any of the fun things. So I expect the world to be very similar 37 years from now. But I'm prepared to be wrong. Happily wrong. So, well, that's going to do it for this week's episode, the 100th episode of Uptime. Thanks again for listening. We really appreciate you. Making it 100 episodes is uncommon, and we don't take it for granted. We appreciate your listenership. We've grown quite a bit in these 2 years. And so, yeah, we're thankful. So please, if you continue to enjoy our work, share the show, leave us a review. And we will see you here next week on the Uptime Wind Energy podcast. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. This is why it just makes sense to install a WeatherGuard Strike Tape LPS upgrade the next time your technicians are going up tower. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.